Okay, there we go. So what would be the correct answer to this first question? What is the null hypothesis for this study? Anybody want to take a shot at it?
Would it be that there's no significant difference between the therapies?
Yes, exactly. So that when we're talking about the null hypothesis, it's always that there will be no difference between the three therapies or the three groups in regard to whatever the dependent variable is. So, and you know, what's here is that there's no change, right? But that doesn't really, that isn't really important. Maybe everybody in all three improves a whole lot, but at the end, they're still all equal. That would still be the null hypothesis, right? That there's no difference between the groups, or no one changes and they're still all equal. So pretty much every time with the null hypothesis, what we're looking for is that there will be no difference between the groups. And then what's a possible answer for number two? There are a couple different things that could be correct. What's an example of a correct answer for what was the directional hypothesis? And here, right, we can just talk about that, you know, one group scored higher than the others. Or that the directional hypothesis would be that the group that received psychotherapy had a significantly higher score than the groups that received the other two therapies, or you know, so that one's going to do better than the other would be directional. Um, and this one I am going to make you all answer, or somebody answer. What's the independent variable here? How are you going to word what the independent variable is?
Isn't it the type of therapy that they received?
Yes, exactly. So the independent variable here is just the type of therapy, right? Because that's what we're manipulating, is that each group gets a different type of therapy. Good. Okay, the type of data you have. So we've got the score on a standardized test is the dependent variable. So what type of data is that going to be? Is that going to
The
be
interval?
Yes, it's going to be interval. So because it's a test score, good job. It's going to be interval data. Um, perfect. All right, so for the question then, what statistical test did you use and why? One person said, I used a parametric independent t-test because a parametric t-test or parametric test has to be done on interval or ratio data. That's partly right. Oh, and I wrote the right answer here. Ha, sorry. So right, the correct answer is an ANOVA. And the reason for that, right? So why would you not do a t-test here? And why would you do an ANOVA?
A t-test only compares to groups, whereas an ANOVA test compares more than that, and we have 3 groups in this case.
Exactly. So that if we only had 2 groups, we would be using the t-test. Because we've got more than 2 groups that we're comparing, we've got the ANOVA. How do we, or why are we allowed to use a parametric test here and not a non-parametric test?
Is it because they had the similar, they both had the phonological disorder and like you were using interval data, so then you would use the parametric?
Okay, good. So it's really because the type of data you've got. If you've got either interval or ratio data, you've got normally distributed data. You've got data that's going to act like real numbers, so you can use a parametric test. If the data was either nominal or ordinal, that's when you'd have to use a non-parametric test for that. And we'll talk a little bit more about that. What would be a correct answer here for what is the p-value? It could either be an exact p-value you could give me, or it could be a range. Where would the p-value need to be or need to have been if there were significant differences between the groups? What's that p-value going to look like?
Does it have to be less than or equal to 0.05 to be
Yes.
statistically significant? Okay.
Yes, exactly. Right. So that if the p-value is 0.05 or lower, right, that's going to tell us that there's only a 5% chance or less that the groups are the same, and that there's a 95% chance or greater that the groups are actually different. So you could say for the p-value, you know, anything 0.05 or lower would be correct, or you could have written like 0.03, 0.01, right? All of those are going to be at or below 0.05 to show that there is a significant difference between the groups. All right. Last question, how many degrees of freedom do you have? So one person had written that because the number of participants is 40 and the number of groups of 2, the degrees of freedom is 38, but that's not actually correct, right? So so first question, what's the formula for how we find degrees of freedom?
Sample size minus parameters.
Yes, good. So what we're going to do in this class, and kind of how we're going to talk about it, is it's the total number of participants minus the total number of groups. So how many participants total have we got here?
60.
Yes, we've got 60 participants, right? We've got 20 kids in each group, 3 groups. So we've got 60 participants. You're then going to subtract the number of groups, which is 3. So the answer for degrees of freedom is going to be 60 minus 3. Degrees of freedom will be 57 degrees of freedom in the study. Okay. What questions do you have about any of that? I'm happy to go over any or all of that, because you'll probably have at least 2 questions just like that.
For the reflection, for the statistical test, I just put parametric. I didn't do the ANOVA. Do I get half credit for that?
On the reflection, I'm really just grading it as far as whether you did it or not. So you'll get full credit for that. And then what I'll do on the final exam, I'll probably have these in a multiple choice format. So you'd have to choose either t-test, ANOVA, correlation, or non-parametric is probably what you'd have to choose from for that.
I have a very specific question about types of data.
Mhm.
I'm having trouble differentiating between ordinal data, like on a scale, as opposed to grades on a test for interval data.
Yes. So, and that is hard to differentiate from. And sometimes there can be a gray area there. What we can do though is to say that if it's like a 1 to 7, you know, a 1 to 5 scale, a 1 to 7 scale, where you're ranking something, that's going to be ordinal data. Where that could end up being interval is if it's like a quality of life measure where you've got 20 of those questions, you're rating each question on a scale of 1 to 7, you then add that all up. What people usually will say with that then is that that final score then becomes like a test score where you have you can have a maximum score if you had a 7 on every answer. And so then it becomes interval data, but that's, I mean, that actually is hard because you could also argue that it's still just a bunch of ordinal data that you're adding up, but usually we're going to call that interval data, but don't worry about that differentiation too much. Is that helpful?
Yes, thank you.
Okay, good.
Can I ask another question?
Sure, good.
Why is interval data, no, sorry, ordinal data not dividable or multipliable? Like, why is a person, like if we're ranking happiness on a scale of 1 to 7, why is a person who's a 3 not half as happy as a 6?
Okay, good. So what we're going to say with ordinal data is that you can't multiply or divide the data, right? So, and really the reason for that is, you know, if we're going to say, all right, rate your voice on a scale of 1 to 7, how happy are you with your voice quality? How it is now. A 1, I'm not happy. A 7, I'm happy. So what we're going to say is if on, you know, on Thursday you said your voice was a 2, and then you come in for therapy today and you're happier with your voice and you say it's a 4, are you really exactly twice as happy with your voice if you said it was a 4 as before you said it was a 2? Or are you just happier now than you were with a 2 and you feel like it's better than a 3 but not as good as a 5? So what people will say here is it's not really, those aren't really numbers, because we could also have you rank and do this, right? And you could say, oh, you know, Thursday it was a B, but now it feels a little better and it's a D or whatever. So, right, because what we're really doing here, a 4 isn't twice as good as a 2. A 4 is just higher than a 3 and a 2 and a 1. Does that kind of make sense? And also, you know, if you really got into this, you know, there probably isn't that much difference between how somebody would rate their voice, whether they'd rate it a 3 or a 4. it'd be almost the same answer, and it would just be almost random whether they picked that. However, there'd probably be a large difference between whether they said it was a 6 or they said it's fantastic, it's perfect, it's a 7. That it's going to take a great day, my voice sounds fantastic, it's a 7, right? It's going to be a huge leap then between those two numbers, and it's not as big a leap between those two numbers. Does that kind of make sense?
Yes, yes, thank you.
So that's the reason why we're, even though that 1, 2, 3, 4, 5, 6, 7, they look like actual numbers, but they're not. How we treat them is not really like real numbers.
I have a question about that.
Sure.
So would you not be able to find, like with ordinal, it's not, you can't divide or multiply. So would you not be able to find like an average of the happiest person if some people do 2 and some people do 5? Is that not?
Exactly. Right. So that's almost exactly what we're talking about here. So, right, because of that, you don't end up having an average. You can take a median and look for what the score was in the middle, as far as, again, my voice rating is higher than these numbers, but it's lower than these numbers. So you can get a median value, but you can't get a mean. You can't get an average score just because you can't multiply or divide. And in order to get a mean score, you divide, right? You add up the numbers and then you divide by something. So yes, that's exactly what we're talking about. And so if you have data that's nominal and ordinal, you have to use a non-parametric test. That non-parametric test then assumes that you don't have real numbers, assumes you can't get an average, and then it will be really strict in giving you a low p-value. It'll say, okay, you've got these numbers, but apparently you're saying because you're using this test, they're not real numbers, so you better have a huge difference or you're not going to get a low p-value. Does that kind of make sense? Okay. You all are asking really good questions about this. Anything else? Any other questions about this? Everybody good? All right, if you do, you can ask them. Let's go to the final exam review sheet, which is being hidden here. Okay. All right, so all right, so let's just kind of go through these. And as we go, if you have questions, all right, so we've got define internal validity and then describe and identify the threats to internal validity. So that is from your very first PowerPoint we did after the midterm. That's the threats to internal validity. Remember that when we're talking about validity, we're talking about accuracy. So how accurate are the cause and effect relationships? We're talking about truthfulness. Are you really studying what you say you're studying? So when we're talking about internal validity, we're saying, what are the factors inside your study that you created that makes us know that you're really studying what you say you're studying and not something else? All right, so, and then as we talk about the threats, that starts to make sense. So, right, threat number 1 is history, something happening outside your study, right? So you are having therapy with a bunch of 3rd graders working on making a good R sound, and you're working on R's. And then towards the end of the study, you realize that most of your participants in group A are also receiving therapy at school, whereas no one in group B is receiving therapy at school. And at the end of your study, it turns out that people in group A did better than group B. Well, was that because of your intervention and your study? Or was it because of something completely different, and that it was really because the people were also receiving therapy at school, right? So again, are you really studying what you think you're studying, what you say you're studying? Is it truthful, or is it something else? So history is something outside your study that could impact the dependent variable, right? So what I'll do on the final is I'll give you a scenario like I just did, and then you'll have to tell me, is that a threat to history? Is that a threat to maturation? Is that a threat to the others, right? So that's history. For maturation, right, a personal change as a result of growth or development, so that if you're doing therapy for aphasia and you're doing vocabulary words and word finding, and people in group A have all just had a stroke recently within the past few months, people in group B had their stroke years ago, right? And that what we know through past research is that people who, the closer you are to your stroke, the more change you're going to make. You can still make a lot of change years after stroke, but it's not going to be as much and as quickly as it would be after it just happened, right? So that would be a threat to maturation, where, you know, the group who just had their stroke was going to learn more, was going to improve more anyway than the group who had had their stroke a long time ago. Just like, you know, if you're working on skills, you know, working on speech sounds with 3-year-olds, right? They're going to improve their speech sounds just naturally. They're going to get better. So have you got a control group of another group of 3-year-olds who are either getting a different therapy or no therapy that you can use then to compare, because all 3-year-olds are going to get better as they mature. That's just a fact of life. So how do you control for that? Does that make sense? Any questions about that at all? Good. Okay. So, and I'm not going to go over every single one, but so threat 3, statistical regression, occurs when people who have scored very high or very low are retested, right? So this is the idea that if everybody in group A is really severe, everybody in group B are really mild, right? The people that are going to improve the most will be the people who were severe to start, because they have the most improvement to make. People who are mild already aren't going to improve that much because they're almost, you know, where they need to be anyway. So just the idea that scores tend to regress towards the mean, so that if you're above average, you've got to work really hard to get higher than that, because odds are they might even do a little bit worse. Whereas people who are below average are probably going to improve and get closer to average in time. Okay. Questions about that at all? Thoughts about that? All right, so we've got 3. You've also got instrumentation to look at, selection, and mortality to look at. And we'll actually talk a little bit more about these too when we talk about your paper in a second. So that's what we're talking about with that. All right. Second kind of piece here, demonstrate your understanding of the difference between a sample, a population, and a census. The population, right, is what you're trying to generalize to. The goal in a study is that your sample, the participants in your study, are as like the population as possible. Now, if you get every single person in the population in your study, so that if your sample is the population, you would then have a census, so that if you were studying the speech sound abilities of kindergartners in Watauga County, and you were able to get every single kindergartner in Watauga County in your study, your participants then would not be a sample, they would be the census because they are the population. Does that kind of make sense? Demonstrate your understanding of nominal, ordinal, interval, and ratio scales. We kind of just talked about that. Any questions about that at all? All right, good. If you do, let us know. Be able to identify positively and negatively skewed distributions. So if you're in a class where pretty much everybody gets high grades, everybody either has an A or a high B, but then a couple people have grades lower than that, is that going to be a positively skewed distribution or a negatively skewed distribution?
Would it be negative?
Yes, good, good, good. And that's not what people usually think when they first hear it, but so most of the scores are high, a few of the scores skew negatively. So that would be a negatively skewed distribution. The opposite of that, right, would be a class where almost the whole class is failing. You have a couple scores that are higher than that. That would be a positively skewed distribution because most of the scores are low and a few of the scores skew positively. You can also have a bimodal distribution where you may have a whole bunch of scores that are low, and then no one's in the middle, and then a bunch of scores are high. And so you can almost take an average of the low scores and you can take an average of the high scores because they're almost two different groups. Okay. Any questions about any of those at all? And for that, I'll give you a scenario, you know, just like I kind of did, and then say, is that positively skewed, negatively skewed, or bimodal? All right. Can you identify the mode, median, and or mean? I'll give you a quick question about that. I think you probably all know that. Let me know if you have questions. All right. Demonstrate your understanding of standard deviation and why it's important, right? So standard deviation is the variation within a group and how far scores deviate from the mean. It's really important because it tells us how predictable the scores are. And that's, I mean, that's really what we're doing in research, right? Is that if we're saying that, you know, the participants in my study were able to do X, well, that's only important if you feel like your client will also be able to benefit from that, right? That how people in the study did then helps predict how your client will do. And so if you have a really high standard deviation, you may end up with a high overall average, right? But if scores end up between a 50 and 100, right? Okay, overall on average people did well, but there's a lot of variability, a lot of variation. Maybe my client will be one who doesn't do as well. Whereas if you have a lower standard deviation, and let's say all the scores were between an 85 and a 95, right? And they were packed in really tightly, you would then be able to say, you know, that then, you know, I then have a lot more confidence that the client in front of me will get a score between an 85 and a 95, and that, you know, he or she will probably do well. So if you just have average score, that tells you a little bit, but it doesn't really help you predict how your client will do the way having the standard deviation does. Does that kind of make sense? Let me know if it doesn't. So, all right, next section, I'll just have probably a couple questions about this. So demonstrate your understanding of normal distribution. If you're given the standard deviation, can you identify the standard score? If the average is 100, what about the percentile rank? So for this, you will go to the data analysis slides. And where are you? There you go. What I'll do is say, okay, you have a client who scored an 85 on their language test. What, how many standard deviations below the mean was their score? Well, they scored an 85, so they were one standard deviation below the mean. Or I might say, all right, your client was in the 98th percentile of all test takers. What was their standard score? You'd be able to tell me that it was a 130. And so just what I'm asking you here is, you know, do you have an understanding then, you know, if another speech therapist comes to you and says, you know, I'm kind of worried, I have a client who isn't doing very well, he got a score of a 70 on the preschool language scale, you'll then have a good idea of his percentile rank and sort of where that client falls on the bell curve with that. Any questions about that, thoughts about that? That's a much harder question if it's not open book, but because it's open book, you'll be able to have the chart right there for you. Right. Okay, uh-oh. Okay. All right, one thing we did not talk about in class was the Z-score. So when we're talking about the z-score, all the z-score is a more exact measure of the standard deviation, right? So that if you, again, if you have a client who scores a 70, they're going to be 2 standard deviations below the mean. Their z-score will be -2, right? So that if it's exactly on this, it's really equal. It's really easy, right? If you get a score of an 85, your z-score is a -1. However, right, most of the clients are going to fall, they could fall anywhere on the curve here, right? So that if you have a client who falls halfway between a 1 and a 2, their z-score will be -1.5. Right, because they're right between the 1 and the 2, or it could be a -1.6, you know, depending on where they fall. So a z-score is just a more exact measure of a standard deviation. All right. Demonstrate your understanding of the null hypothesis. You kind of did that already for me, right? Just the null hypothesis is always that there's no difference between groups. There's no difference between anything. All right, state the relationship between a sample size and a p-value. So remember that when we talked about what a p-value means, and it means what are the chances the groups are different, what are the chances the groups are the same. So as the sample size goes up and gets larger and larger, and maybe you get 1,000 people in each group, and then you put that data into that statistical test, right? If there's any difference at all in the data, the test will say, yes, this is probably a real difference. You've got lots of people in the group. So we're gonna drop your p-value because it probably means that there's a real difference. If you've got tons and tons of people in there, it's probably a real thing, right? But yet if you've got 9 people in group A, 9 people in group B, and you have exactly the same amount of difference between the groups, right? So your sample size goes down, you only have 9 people, your p-value goes up because your test will say, yeah, there's a difference, but maybe it's just random difference. So the higher your sample size, the lower your p-value. The lower your sample size, the higher your p-value goes. Does that kind of make sense? And that's because remember those tests and the p-value aren't actually saying there is a difference. It's just saying there probably is one or there's probably not one. And the more people you have, the more confident you can be. Okay. All right. Again, just kind of yell at me if you have a question about any of this. All right, discuss what it means that the significance level in most studies in CSD is set at 0.05, and what does that mean? So how would you explain to a family member that, you know, what does it mean that we set our p-value at 0.05?
I mean, would it be if it's less than, then there's a bigger difference, and if it's more than, then there's not as much of a difference, or is it flipped?
All right, you're close, you're close. Except what you have to remember is that it doesn't mean that the difference is actually larger or smaller. It doesn't really have anything to do, I mean, it kind of does, but it doesn't actually tell us how large the difference is. what is it that the p-value tells us? You're close though, you're super close.
Would it be that if there is more than a 5% chance that the difference is random, it would not be statistically significant and you couldn't use it for your research?
Yes, 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 right? So that what that p needs to be at or less than 0.05 means is that we have to be 95% sure that there is truly a difference. So it doesn't actually tell us whether there's a large difference or a small difference. It's just telling us whether or not there is a difference and what the chances are of that. So that in order for us to say that one thing works better than another, we have to be 95% confident that one group is different from another. And that what that p-value, what that 0.05 means is that there's a 5% chance that the groups are the same. And so if you get a p is 0.03, that means there's only a 3% chance that the groups are the same, and there's a 97% chance that groups are different. Does that kind of make sense? Any questions about that? Thoughts about that? Okay. All right. All right. So, and then this is kind of what we just talked about, right? An understanding or identifying when results are statistically significant, right? So again, if the p-value is at or lower than 0.05, that means that differences are statistically significant, that we're at least 95% confident that there's a true difference between groups. Okay. All right, provide or identify an example of a type 1 research error. Okay, so if you get, a p-value, you do your study and you get a p-value of 0.03 and you throw a party because your groups, according to the p-value, your groups are probably different. You can publish the findings. That's great. But what that p-value means, right, is that there's a 3% difference that in reality, the groups are the same and that there's actually no difference between the groups. So that if you have a p-value of 0.03, you're allowed to say there's a difference because there's a 97% chance there is a difference. However, 3% of the time you're going to be wrong, right? So that's a type 1 research error, is when you claim that there really is a difference between groups because you get that low p-value. However, you're incorrect. Okay. A type 2 research error is just the opposite, right? If you do a study and you get a p-value of 0.12, right, you have to say that there's no difference between the groups because that p-value is larger than 0.05. However, what that 0.12 p-value means is that there's only a 12% chance that groups are the same. There's actually an 88% chance that the groups are really different. However, we have decided that we have to be 95% sure that groups are different before we can say that they are. So a type 2 research error is when you get a p-value higher than 0.05. You have to then say that the groups are the same, but that in reality, if reality exists, there really is no difference between, or there really is a difference between groups, but that you had to say there's not because your p-value is above 0.05. Does that make sense? What questions do you have about that? Right, and so really all of this just goes back to, right, you really don't ever prove anything in science. All you're saying is this is probably true or this is probably not true. The groups are probably the same or they're probably not the same. That's kind of all we're doing. And that's all the p-value tells us, is that this therapy probably worked better than the other therapy, or probably didn't work better than the other therapy. We can't ever talk about anything for sure. All right, calculate degrees of freedom in a given study. We did that at the opening, right? It's just the total number of participants minus the total number of groups in the study. All right, provide or identify an example of a parametric test, right? So a parametric test is either a t-test, an ANOVA, or a correlation, or the big ones we talked about. We talked about already, so the purpose of a t-test would be to find out if there's a difference between two groups, right? And you can only do it, because it's a parametric test, you can only use it if you've got interval or ratio data. Identify or propose a study in which ANOVA would be used. So it's really the same thing, except that if you've got more than two groups and you've got interval or ratio data, you're going to use an ANOVA. All right, now, so, all right, kind of the same question. If you've got either nominal or ordinal data, you have to use a non-parametric test. If you've got interval or ratio data, remember, you can use a parametric test. All right. Which test is more conservative? So can anybody answer that? What does it mean to say that one test is more conservative than the other, and which test is that? Okay, so, and actually, one of the best examples of this is the one that Hannah asked, is how do you know if something's ordinal or is it interval? Like if you're ranking, but it ends up being a test score. So you get your data, you decide, yeah, it could really go either way. You put the exact same data into a non-parametric test and the exact same data into a parametric test. The non-parametric test is going to give you a higher p-value because it's more conservative. The non-parametric test will say, you're using me because you don't have real numbers, you've got nominal or ordinal data. So unless you have a huge difference, we're going to keep your p-value high and you're not going to be able to say that there's a true difference. Whereas the parametric test will say, you're using me because you've got real numbers, you've got either interval or ratio data. It's going to give you a lower p-value on the exact same data. So it's going to be more liberal in allowing you to claim that there's really a difference. Does that kind of make sense? Any questions about that?
You said non-parametric, correct?
Is more conservative. That's right.
Yeah.
Exactly. Yeah. It'll give you a higher p-value on the exact same data. All right. If you have questions about that, let me know. Let me make sure I haven't missed any chat questions or anything. With how the screen is, I can't see any chat information. No, I don't think so. Okay. All right. So where are we here? Good, good, good. Oh. Okay. So almost done with the exam review here. So understand and identify correlations of the direction of the relationship, right? Is it a positive correlation where when one thing goes up, the other thing goes up? Or is it a negative correlation where when one thing goes up, the other goes down, right? We just talked about, sorry, I'm going to be moving stuff back and forth. What did we just talk about? All right, the relationship between sample size and p-value, that's a negative correlation. When the sample size goes up, the p-value goes down. When the sample size goes down, the p-value goes up, okay? Okay. All right, so that's direction. We've also got strength of the relationship. That's where the R value can go between -1, goes across 0 to +1. The farther away from 0, the stronger the relationship is, right? So that if you have an R value of like 0.1, it's not strong at all. There's probably no relationship there at all. Whereas if you have an R value of -0.9, you've got a really strong negative correlation, right? So the farther away it is from 0, the closer it is to either -1 or +1, the stronger the relationship. We talked about in class how you can also get a significance, so you can get a p-value. The danger of that is that all the p-value will say is if there probably is a relationship or there's probably not one. So you could have a really weak relationship, but if you have enough participants, again, as the sample size goes up, the p-value drops. If you get enough participants, you could get a p-value lower than 0.05. You can say there's a relationship, even if it's a really, really weak relationship, but it's going to say that there is one. So those are the three ways of looking at correlations. You talk about the direction, talk about the strength, and or talk about the significance. Last things, tell the difference between statistical significance, where we're using the p-values, practical significance, where we're looking at effect size and Cohen's d and talking about how large the difference is. Clinical significance, talking about does it move the clinical label of the group from severe to mild, from mild to within normal limits, and then looking at personal significance, right? Was it important? Were the changes in therapy important to the client and family? So what I'll do is give you a scenario, and then you'll just have to tell me you're looking at personal significance, you're looking at practical significance, clinical significance, or something like that. Okay. Any questions about any of that?
Did you say something about, sorry, I'm going to go back to the, what was it? The correlations of stuff.
Yes.
You said something about a -1 and a +1. Is that different than like how far away it is from 0 or?
Right. So you've got -1 and then you've got 0 and you've got +1, right? So anything, you know, usually anything about 0.75 through +1 is going to be strong. And likewise on this side, negative 0.75 to -1 is going to be strong. But the closer it is to 0, the weaker it is. And the closer to either +1 or -1, the stronger it is. Does that help? Is that what you were asking?
Yes, thank you.
Sure. Okay. Any other questions about any of that at all? All right, let's talk about your method section. So what you're going to do when you turn in that final paper, this is the final paper template here. When you turn in that final paper, you'll use this cover letter for me, and you'll let me know if you did not or you did revise your lit review, and if you did, what you changed. You'll give me your lit review, and then so sort of chapter 2 will be the method section. You're going to have that in bold at the top. You'll give me the purpose just to help remind me of the purpose of your paper. You'll do the participant section like we talked about. You'll give me a table, right, with either 4 or 5 of your inclusionary criteria, one of which will be your dependent variable. And then you'll give me a p-value. And what you're going to do, so what this is, you are doing a study, you're doing your dissertation or your master's thesis. You write up your literature review, you write up your method section, you then present that to the faculty. And part of your method section is you say, here's my criteria for who's going to be in the study. Here's the data I'm expecting to get. And then here's a p-value I'm hoping to get. So you have, as you're writing this, just like you would do for real, you have not actually gone out and recruited people yet and pre-tested. You're just saying, this is what I'm expecting to get. Now, what do you want your p-value to show? Do you want your p-value to show that there is a difference between groups at the start of the study? Or do you want your p-value to show that there's no difference between groups at the start of the study?
I mean, would you want there to be a difference just to show like one, I mean, for me, like 2 therapy session or 2 different types of therapy? Like, are you wanting to show that one is more significant and effective than the other? Is that what you're asking?
Okay, good. That's exactly what I'm asking. So which would be better? If at the start of the study, groups were already different, you did the study, and then at the end of the study, the groups were still different? Or would it be better if at the beginning of the study, the groups were the same, you did the intervention, and then at the end, the groups were different?
It would be better if the groups were the same in the beginning, and at the intervention, there is a difference.
Exactly, exactly. Good, good, good. So you want to, so you are totally making up a p-value here. So I want you to make up a p-value that shows me that the groups are the same at the beginning. Yeah. And remember too that if you give a p-value of like 0.09, like, yeah, you can't technically say that they're different, right? But that 0.09 means that there's a 91% chance that the groups are actually different. So give me a p-value that shows me, yeah, maybe they're different, maybe they're not, right? At the beginning. And then if at the end, if you have a p, you know, obviously you aren't gonna actually do the study and then present results, but then at the end, if you did that and presented results and you got a p-value of 0.03, and you could say, wow, I showed you at the beginning the groups were the same, I did the study, and at the end they're different, right? That's a really powerful way to show change, to show that because of what you did, because of the intervention your participants had, that's why they're different. Okay, wait, let me try to grab, I've got too many tabs open here. Let me try to grab, right, so in your method, you'll have participants, you'll tell me all this good information here, and then materials and procedures, and we've kind of talked about this. Let me see. Sorry, let me go back to where we were. I want to leave time for you to ask too. So, all right, so what questions have y'all got about the method section? And remember that this really is like a recipe in a cookbook, right? You're going to write down exactly what you're going to do so that if somebody wants to come along and do the same study you did, they'd be able to do that.
So you put a note in the comments after I turned mine in, and it was just saying that I can refer to ASHA as either ASHA organization or the ASHA, like, you know, just the little ASHA, or I can like completely write it all out. Is it just because I'm not sure why?
Okay.
So just,
All
I
right,
don't have to say like the ASHA organization. I can just say ASHA.
all right, so good question. The first time you write it in the paper, you've got to write it all out. So you've got to write the American Speech Language Hearing Association and in parentheses ASHA. After that, you can just refer to it as ASHA.
Okay. Okay, awesome. Thank you.
Sure. Anything else?
For the representativeness of participants, what kind of information are you looking for written there other than like their requirements and their characteristics?
Okay, great. So I just want you to give me one sentence about how representative or who are your participants representative of? So if I'm doing a study here in Boone and I've got preschoolers who stutter, all my all my clients are white, they're all from middle class families, and they're all from Boone, are they representative of all preschoolers who stutter? Are they representative of all preschoolers who stutter in the US? Are they only representative of preschoolers in Boone? There's no real right answer to this. I just want you to have thought about that, right? Because I could probably say that they were representative of all English speaking American preschoolers who stutter, just because there's no research out there that shows that people of different races or ethnicities are more likely to stutter, more likely to recover from stuttering, respond differently to therapy. So that's probably not a difference. However, the socioeconomic status, right, will make people, the more money you have, the easier it is to make it to therapy sessions, to have transportation, to have support. So I just want you to have thought about that. Just give me a sentence that shows that you thought about it, and it'll be correct, no matter what you say.
Okay, perfect. Thank you.
Yeah, awesome. What else? Anything else? We've got 6 whole minutes.
I have a question about the midterm. Is it mostly multiple choice or short answer, or is it like mixed?
Right. So,
or the final, sorry, not the
right,
midterm.
right. Yeah. So a lot of it will be, I'll give you a scenario and then you'll give me the answer, usually in multiple choice format. I might have a couple fill in the blanks and things like that. But more often than not, it'll be multiple choice. I don't know, is that helpful at all?
Mm-hmm.
Okay. Anything else? All right. If you have questions, please go ahead and you can email me. I also have my, I will have office hours next week, next Monday, Tuesday, and Thursday mornings. So if you have questions, feel free to go ahead and ask me to do a Zoom, and I'm happy to do that. So. Happy Thanksgiving, everybody. Good to see you. Have a good break and let me know if you need anything.
Have a
Thank
good
you.
bye, Dr.
Happy
Klein.
Thanksgiving.
Happy Thanksgiving.